Okay, so now I'm gonna show you how to charge a battery from a lab power supply. There are some ground rules that you should follow. I don't always do that, but you should do it. I have misplaced my diodes. Where did I put them? Ah, here they are. So, if you know what you're doing, you should be fine actually charging the battery directly from the power supply. But even though you know what you're doing, accidents can happen. So I can show you what you're supposed to be doing, or at least that's how I would do it. So you need a big diode. This is, I think they're rated for like 50 amps or something. It's solar panel diodes. They are very cheap on eBay, so you can buy them in large quantities for a fairly low price, and by large quantity I mean 10 or more. I will explain what this diode will do for you. So I can actually show you something on my power supply, since I know it can take it, but if you have a look here, this is a generic 12 volt 10 amp hour lead acid battery. The current, I think it's actually pretty full. Yeah, we have 12.53 volts in here, so it's almost full. But what many people like to do is to connect up your battery to your power supply and then turn on the power supply, or for some reason do that. What you actually can do then is destroying your power supply, at least if it's a lab power supply. So currently my power supply is off. I haven't enabled any external power source to it, but if I actually put on the voltage here, it will start up. So we're backfeeding the lab power supply, and that is not always a good thing to do, or very, very seldom it's a good thing to do. So what you would like to do is to turn on your power supply, and then it's critical that you enter the correct voltage, which in my case will be 14.7 volts. I hope you can see this. It says 14.7 volts here, and then I push on and we get 14.69, so 14.70. And now we know that the power supply actually has higher voltage than the battery. So then the battery will be charged by, or fed by, the power supply. So now it's safe to actually put in the leads to the power supply and put it negative to negative and positive to positive. I will see that it's charging, and since it was almost full, it went straight up to 14.7 volts, and I had the current limiter set to 2.6 amps, and we're currently putting 0.6 amps, so we're way under the current limiter. But what you should do, since you can have power failure and stuff inside the power supply, and then you will be backfeeding the power supply and it will eventually break, you should take one of these diodes take out your multimeter and see what the forward voltage of this diode is. And it helps if I got the correct setting on the multimeter. So we have 154 millivolts forward voltage on this diode. That sounds suspiciously low. I think they're rated for 300 millivolts. So, but to be on the safe side, we will use 150 millivolts. So what you should do then is, you see this little white strip on the diode? That marks the cathode side. That's the negative side. So you want to connect the positive lead to the positive side, like that, because the diode will only allow the current to flow in the direction of the diode. So positive will go through the positive side out to the negative side, and we'll put it on the battery like that. Yeah, like that. And then we can put the negative on the negative side. But since we had 150 millivolts of forward voltage on this specific diode, we have a voltage drop of 150 millivolts. So what the battery is actually seeing right now is not 14.7 volts, it's seeing 14.55 volts. So we need to adjust the voltage to be 150 millivolts higher. So I'll put it to 14.85 volts. So now we should have 14.7 volts on the battery. But I think the voltage drop measured by the multimeter on the diode was incorrect. So let's see what we actually have here. Yeah, we have 14.5. So I have 200 millivolts to go. So I will adjust the power supply to 15.05 volts. So now we have 15.05 volts on the power supply, and we have 14.7 volts on the battery. Yep. So here you can see 14.04 volts, 5 volt actually, but yeah. And now when I turn off my power supply, the power source to it, it will also turn off the power supply itself, since we're not able to backfeed via the diode. So there you go. Now it's off. And that's why you should use a diode when you're charging a battery, since you can have power failure in your lab power supply. So this cheap little component is a great way to protect something that is way more expensive and took a lot of time to build. So that's how you should charge a lead acid battery from a lab power supply. And of course you should remember to have a current limit there as well, so that you don't try to charge this battery. Let's say if it's 10 amp hour battery, you shouldn't charge it at 10 amps. thing's actually rated. It says less than 3 amps on it, so you should never put in more than 3 amps on your current limiter, since it might hurt the battery. Yeah, that's pretty much it. If you do it like this, then you're pretty much safe. Thank you. Bye.